Guys, I have a quick puzzle for you. It's a good test of your observation skills. Are you guys ready? Yeah. And the question. Now, let's see how many are able to recall what you guys saw and are able to answer the question. So if you guys want to become good detectives, you should be able to answer this question now. What objects did you observe in scene 1 and scene 2? Are they same? Simple. Okay, so I'm sure you guys have your answer. Let me play it again. Hey guys, what is the answer? So in scene 1, these are the objects which was on the screen, and for scene 2, these were the objects. Now the question is, actual question is, what is the count of objects in each scene? How many are there? Clearly we have 7 objects, and here too we have 7 objects. So what is the count of objects in each scene? Yes, it's 7. Now an important question, did the order in which they appear matter when it comes to count of objects? Count of objects. Did it matter? Answer is no. Right. Just because the order changed, the number of objects did not change. So the order did not influence the total count of the objects. Okay, so that's that. Let's look at the basic idea of what we are learning. So the heading, I missed the heading. So the heading is to do with something called as commutative law, that is swapping. So this video is to do with commutative law. The commutative law, commute. Do you guys know the meaning of commute? Meaning of commute. Commute means what? Commute means movement. Commute means movement, right? So what is moving around over here? Here, numbers are moving around. Here, numbers are moving around. Don't worry, we will see this. So we have one more scenario. The order of numbers in an addition or multiplication problem does not affect the sum or product. That's a statement. That's the basic idea. Let's think of it this way. So we have one more scenario. Buying 3 apples followed by 4 oranges gives you the same total as buying 4 oranges first and then 3 apples. It's similar to the scene that we saw, right? It doesn't matter in which order they came. End of it. Yeah, end of it. This and this are, the counts are one and the same. Do you guys agree? The counts are one and the same. So here too the counts are 1, 2, 3, 4, 5, 6, 7. Here too the count is 7. And here too there are 4 plus 3, 7 fruits basically. So in general, if I happen to see numbers like 5 plus 3, which is equal to 8, I can rewrite this as 3 plus 5, which is also equal to 8. You might be thinking, what is the point of this? This will be useful when, say, you have something like this. 206 plus 1467 minus 6. Would it not be convenient if we had 206 minus 6 plus 1467 to do your work? Which is faster? Which is faster? Is it not? Case 2 is faster. This is faster to calculate. Do you guys agree? Because this operation leads to a very simple number, and handling 100 is much easier than this complicated sum, right? And so we make use of commutative law to move around terms and so on and so forth. Okay, guys. So in general, a plus b, these are two variables, is equal to b plus a. And when it comes to negative terms also, we can think of negative term as a plus of minus b, which is also equal to minus of b plus a. So we move the entire number with its negative sign. So remember, 7 minus 4 is not the same as 4 minus 7. This is not it. A very important note. This you guys have to keep in mind. 7 minus 4 is 3 and minus 4 plus 7 is also 3. While 7 minus 4 is 3, yes, but 4 minus 7 is minus 3. So this is 3, which is not equal to minus 3. So that's one thing about negative sign. You have to keep negative sign with the associated number when you are commuting it. Here as well. Minus 6, I saw to that it shifted when it got commuted per se. Even the sign also moved. That is something that you guys have to keep in mind. That's where most of the people go wrong, if they do go wrong. If not, it's a very simple topic. Same holds good with multiplication. A into B is same as B into A. That is 6 into 4 will give us the same answer as 4 into 6. Here too, we have 6 into minus 4, which is equal to minus 24, which is same as minus 4 into 6, which is equal to minus 24. Again, just take in the idea. Don't think too much. Now, why does this work? Why does multiplication of, say, 6 into 2 give us the same answer as 2 into 6? Okay, let's deep dive into this. The first thing is 6 into 2 means what? Means 6 is added 2 times. Right? 2 into 6 means what? Remember, multiplication is repeated addition. So 2 into 6 means what? 2 is added 6 times. 2 is added 6 times. And 6 plus 6 leads to, yes, 12. While 2 plus 2 plus 2 plus 2 plus so on and so forth leads also to 12. And that is the reason. Okay, so that's a very simple reason. And this is your commutative law. So commute means movement. We are moving around numbers. So here we had 3 plus 4 objects is the same as 4 plus 3 objects, which leads to the same count.